Hey guys, this is the lever simulation that we're going to be using for this experiment, I guess you'd call it. So what we're trying to see is how does this lever work? So the lever is this long gray thing that you see here, and on one end we have a 1 Newton load. So now I'm going to push down with this little spring gauge on the other end, and I'm going to see how hard I have to push on this to be able to lift up that 1 Newton load. So you can see when it comes to a balance, it's about 2 Newtons that I have to push on when the fulcrum is much closer to the applied force, which is this end here. Um, so what happens if I make this lever arm longer on this side and shorter on this side? What's going to happen to that force? Well, so I moved it a little bit, and once this comes to a balance, you see that it dropped now from 2 Newtons down to 1.4. So I'm going to make that even longer. And you'll see as this comes to a balance that now the applied force is only about 1 Newton. Okay, so I'm going to move this a little bit further so that the lever arm on this side is longer and shorter on this side. And you see now this is requiring even less applied force. So I'll move it one more time. And now you can see as it equals out that the applied force is only about 0.5 Newtons. So the longer the lever arm is on the side of the applied force and the shorter it is on the side where the load is located, the smaller the applied force that's necessary to lift this load. So when you're using a lever, the idea is by placing the fulcrum closer to your load, you can actually lift a pretty heavy load with a relatively small force.